October the 7th, 2016. This is John Stanley. This is an overview video describing how the leaflet sensor on OB machines should work. The sensor I'm holding is an EMX UV sensor. It's installed on OB Digit 1 and it's designed to pick up optical brighteners that have been added to inks and glues. Optical brighteners make white paper look brighter to the sensor, or in the case of clear glues, the 360 nanometer wavelength from the sensor excites the brighteners that have been added and the clear glue becomes luminescent. The sensor has multiple settings internally to define how sensitive it is. The sensor in this video is the same model as installed on Digit 1 and has been adjusted to optimal settings and tested using the same physical distance as on Digit 1. Here's a demo of the sensor looking at brown cardboard of the box, the tampon and the wrapper, the green string, the white divider inside the box. On the machine, the distance from the sensor to the tampons is about 2¼ inches. And we'll also take a look at what happens when the sensor sees red. So, for starters, let's talk about the display before we start looking at product. On the display, we'll see a number change from 0 to 50. Right now, the sensor is showing 0. 0 means that the sensor does not see anything that it considers to be optically brightened. 50 means that the sensor sees the maximum value back from the target. Ignore the 2 decimal points that are in the display. They have nothing to do with the number itself. They're indicators which show you the power level of the sensor. So we're just going to focus on the 0 to 50 value that we get back. So let's start with a white OB tampon that is wrapped in the polypropylene. And I'll start right at the face of the sensor and I'll move it out, and we see that we have at maximum a value of 1 to 3. All right, and now we'll look at the green string, and you can't see it, but I can see where I'm shooting the UV light onto the back of the product, and we see a maximum value of 3 out of 50. And now what we'll do is we'll actually take a red tampon, and we, at different distances, we see that the sensor doesn't see the red tampon. We'll take a white wrapper, and there are no optical brighteners in this wrapper, even though it's white, so it doesn't see it. We'll rotate it so that we're looking at the red. There is no optical brightener in the white paper, so there's no bleed through of that brightener through the red ink. And now we'll actually go one step further and just look at an entire box to see what happens when you go across it. So we're shining on pink, white. So we have very low values. We're reading up to maybe 2 or 3 in general for this box. And now we'll look at another manufacturer's box. We'll start at the white, move over through the pink, all the way to dark red. Nothing. And now we will look at our own box for OB product. And we will see that at any distance, the sensor is not seeing the box. It's getting a little bit of feedback from the brown. That could be due to some particles that are mixed into it, especially if there's any recycling. And we look down into the dividers, even the white side of the divider, no feedback to speak of. So this is a good point to mention that between 0, which means nothing, and 50, that means maximum feedback, you can set a value in the sensor that is a trip point. So let's just say we pick 25, that's halfway. So any number that comes back higher than 25 is considered good, whatever the target is, and any number less than 25 would be a reject. So now let's look at paper that has optically optical brightener is added to it. So here is a piece of 98 bright copy paper, standard copy paper, and we're reading 50 all the way to the face of the sensor, and way away from the sensor we still have a very high value of 37, 38, 40, and we are working in about the 2.5 range, 2.25 range, 50 maximum feedback to the sensor. No problem seeing optically brightened paper. That's copy paper, and they do put optical brighteners in that. And when you buy it from Staples and you get it either 88 to 98, it's the optical brighteners that are actually making the paper jump out, and that's what this sensor picks up. Let's look at the leaflet that we're using. So we shine it at the white, 50. Nothing, 50. Even when we're up on the green section, the optical whiteners underneath of the ink are still bleeding through. And you see we get back to the white in the OB, and now we're back up to 50. The red strip is a little small to really focus just on it, but I'll sneak over to it here. And you see that it's still 50. So you say, well, is it picking up the red? No, it's actually seeing the optical brighteners bleeding through. Remember, the white paper here has an optical brightener in it, and the ink is printed over top of it, so it's not completely opaque. All right, so now let's look at an application of the leaflet in a box. So about 2.25 inches away from the face of this flap is the distance that we're installed on the machine. We see nothing with the cardboard. We see the leaflet sitting in there. If a tampon jumps up and gets into that leaflet space, we do not see it. If we look at a void, we do not see it. And good explanation is if we just go over here and start looking around anywhere in this region, we don't see anything. Shoot it in at an angle, nothing. So it doesn't pick up a single thing in this box except for that leaflet. So as long as we can maintain this sensor picking up some region in here, we can detect reliably that the leaflet is in the box. And again, this is 2.25 inches. That's what we have it set on the machine. So we pretty much have almost maximum feedback. And you can even shoot it at an angle and still pick it up. All right, so now I'm going to show a box where we have actually flipped the booklet so that it has the red band at the bottom, because the booklet can be put in, or could be put in, 2 different ways. So here's that example. But you see that we still see it, because what we're seeing really is the little bit of bleed through on the red band, but we're seeing all this white from the leaves that are folded back and forth. So as you can see, the sensor does an excellent job of detecting the leaflet and ignoring the box or tampon, and it's just as critical to be able to ignore these items to prevent false OKs due to tampon misposition.